This is TempleOS 5-Minute Random Code Walkthrough, Episode 18, and I'm your host, Terry Davis. So let's see where God sends us. Alt-B. We are in weblog. Okay, this is where I generate my website report. If you want to see what my report looks like, well, let's go to the, I'm going to go to the, my version is a little bit expanded, but on the distribution disk, there's in the demo directory, there's a weblog example. This is almost identical to my version. So it has a couple data files, which are weblog files. And it has, I scrambled the data files so that nobody's IP would be reported, IP address. So this is the index report. Okay. So what this program does is generates a weblog report. That has hits during the hours and how many hits. Those are single hits. This is the source of the where for hits on my index page. This tells where it came from, and then I have downloads reported. So this is each one of these is a download, and then it keeps track of duplicate people who download it twice. It gives me a duplicate report, and then this tells where the person who downloaded came from. Okay, so the first thing we have to do is parse log files. It makes a queue of log structs. A log struct is a circular doubly linked queue. That's with the next and last. Then it has a tree. I went ahead and made it so I could put it into a tree left and right for the IP number. It has the IP number. It has what is code? I don't remember. It has the size. This is the size of the download. So sometimes you get a partial download, and I want to filter those out. I only want complete downloads. So this tells. So if you look in the log. If you look in the log file, it tells I don't know what this code is. Maybe that's what I save. I save that code. I don't know what it is. I could look it up, I guess. This is the number of bytes that they downloaded, and this is the source. Oh, this is the file this is my website file that they downloaded. That's my ISO file. This is how many bytes, and let's focus on the things that are unique to TempleOS. So parse single log file. So we use the document framework. We read a document, the name, then we want plain text with tabs. That means has \T. So tab is not a separate command. A document is also a circular linked list, doubly linked list, and we want to double $ so that they show up right. So when we're parsing this, we go through the whole file. starting at the root or the head of the queue, and when we process all the document. This is the document entries, and if it's a text entry, not a carriage return, that's the only other one, carriage return. Then we allocate one of those log structures that we just prepared, and now we source is going to point to the text of the log entry, and we convert the this is like string to unsigned long in the C library, string to I64, and it gives the end pointer. And if it's not a dot, we skip it. Then we do the next one. So this is the 4-byte IP address. And okay, if it hits the end, we throw an exception. Otherwise, we wait until we hit the bracket. Then we do the date and string to unsigned. Okay, so the date is a multiple entry. We have to set the month, day, hour, minute, second. Then when we get all done, so I convert it to one of my date times. Structure to date. Structure to date will convert a date structure to one of my I use a 64-bit date time. The low 32 is the time of day. The upper 32 is the day since Christ. Since it's anyway, it's an integer. So then we parse the get, and we go ahead and allocate into the log structure node. We allocate a string for the file. Then we allocate a string for the link where the person came from. Then we insert it into the queue, and we process the whole document. And this process is, if we have multiple files, then this process is multiple files. It does a find files in the current directory, searching for a certain mask, and then it processes all the entries in the list and then deletes the list of files. And when we're cleaning up, we delete all the. Here's how we delete a log. We delete the allocated file, the allocated link, and then the node itself. So this deletes all those. I have certain I block my own IP address. I don't include it in my statistics. I think I make a queue of blocked IPs. Is blocked, searches the queue, just a linear search because it's just a couple numbers. These are my own IP addresses, I guess. Anyway, I've changed a couple times over the years. I haven't updated it anyway. So it filters out robot entries, and it removes the blocked IP numbers. It goes through the list, and if it's one of the blocked ones, this checks if it's a download. I want to record statistics on how many downloads, and this checks if it's greater than my file size threshold. I want to throw. Sometimes you get 100 little tiny download nibbles. I filter those out. I just want full downloads. I make a tree for the IP numbers so that I get rid of duplicates. So I record non-duplicate IPs. Then I make a tree, a binary tree of the the source location for when they clicked on getting to my web page. This is where they came from. I make a tree that it sorts compares one link to another link when it's adding to the tree. It goes to the left tree or the right tree to finish, and if it's found its correct spot, then it inserts a new tree link entry. You have to be careful because this is a recursive call, and the recursive call stack is limited size. So I think I put if we run out of stack, I'd throw an exception. We only have, I think, 128K of stack. I did it kind of small, I guess. Anyway, that's because we don't use paging. So this will traverse the links and print the tree. This download report, so this reports the downloads. It goes through the checks the date times. They're in date time order. When you run the program, it asks you for the a range that you want to display. So this checks if it's in the range, and if it's a download, and it displays it. It counts up. Anyway, so that's this program. It's